All right, so now I'm going to go through and define for you two-way tables, marginal distribution, and conditional distribution. So two-way tables, and actually the two distributions here are things from Algebra 2 curriculum when we had our stats unit there. But a two-way table is used to describe two categorical variables, one of which will be the row and the other one will be the column. So for example, I could have something about gender and then like car accidents, whether you've been in one accident, two or more accidents, or five or more accidents, things like that, where I'm comparing two categorical variables. Marginal distribution is the proportion of each cell out of the table total. So all values in the individual cells should add to 1. Conditional distribution are the kind of outermost row and column, and it's the proportion of each cell out of the row or column totals, and each row or column should add to 1. So you've dealt with two-way tables in the past. This is kind of just a brief introduction. What I want you to look at on the next page are graphical displays of two-way tables. So I have a two-way table here. It's environmental club, either yes or no. And then snowmobile use, never used, you're a renter or an owner of a snowmobile, and it has some totals there. This here is a really good example and one that I want you to read through to learn about the different ways you can represent a two-way table. There's the side-by-side bar graph, there's the segmented bar graph, and then there's the mosaic plot here. So what I want you to do is just take about 30 seconds, pause the video, and read through this page with the example problem, and then press play to make note of some key things that I want you to be aware of. So some key things I want you to be aware of is that these three distributions are all representing the same set of information, but they give you the information in a little bit of a different way. I want you to notice the similarities between a side-by-side bar graph and this stacked one here, because the bars and the size of the bars are all the same. It's just here they're stacked on top of one another, and here they're right next to one another. This visual is sometimes really nice because you can get a really good comparison of the frequency percentage between them. So I just think that this gives you a really good visual of how they compare and looks a little bit more neat and organized in comparison to the side-by-side. Mosaic plot is something that the AP Stats curriculum people added in a year ago, and mosaic plots are nice because of the fact that they give you a little bit more information than actually these two do. So what's nice is that this size, this width of those that say no in comparison to those that say yes is exactly proportional to the number of people that said no in comparison to the number of people that said yes. And that's something that these other graphs are lacking. We really can't tell how many people said no in comparison to how many people said yes out of the two-way table. But if we look at this mosaic plot here, I can see that out of all the percentages of how people answered to owning a snowmobile or renting or never used one before, that there were so many people that initially, though, said no to being an environmental club member. And then there was very few people that said yes. And so mosaic plot gives you the same information, but even a little bit more information than the first two do. At this point, you should be able to, on the next page, fill in the definitions of side-by-side, segmented bar graph, and mosaic plot for you to refer back to.